Greetings, this is Mr. Caslin. I had lots of pre-calculus students have questions with these double angle equations this week, so I wanted to go over a basic one and show you how to solve this. So we're saying that the cosine of this, twice of this angle that we're looking for is -1/2. Well, let's solve this. Let's solve for 2 theta. So you're going to use an inverse. Okay, so think about where is, what angles have a cosine of -1/2. So -1/2 is in your second quadrant. In your third quadrant, and the reference angles are going to be 60 degrees. So it's going to give you a 2 pi over 3 and a 4 pi over 3. Right, so those are the solutions to the double angle. Now we're in search of what theta is going to be. Okay, so first of all, think that for the double angle, these solutions are 2 pi over 3, and remember the general solutions are 2k pi. Right, k is our counter. Some teachers use n, so if you use 2n pi, it's the same thing. Okay, so if we were solving this for 2 theta, these would be our solutions. 2 pi over 3 plus 2k pi and 4 pi over 3 plus 2k pi. But we're interested in theta. So the first thing we do is start dividing everything by 2. Okay, if you divide 2 pi over 3 by 2, you're going to get 2 pi over 6. 4 pi over 3 divided by 2 is 2 pi over 6. Now, you're going to divide your general solution also. You're dividing this by 2 and this by 2. All right, so what's going to happen is your solutions for theta are 2 pi over 6 reduces to pi over 3. 4 pi over 6 reduces to 2 pi over 3. Now your general solution is going to reduce to just a k pi and 2 pi over 3 k pi. Now this problem, I didn't write it down, but this problem said find all the solutions between 0 and 2 pi. So you're going to take your solutions here, your general solutions, and let's keep adding up until we've reached 2 pi. Okay, so think about that. So our solutions between 0 and 2 pi, we're starting at pi over 3. We're adding another pi, so think of that as 3 over 3. So 1 over 3 plus 3 over 3. So you're going to get 4 pi over 3. Keep adding another pi, another 3 over 3 is going to give you 7 pi over 3. Excuse my writing. We're not going to use this one anyway. Notice we've exceeded 2 pi, so we're throwing this one out. Okay, come down to here. Starting at 2 pi over 3. We're going to add another pi. Another 3 over 3, which is 5 pi over 3. You can keep going, add another pi, which would give you 8 pi over 3, but we would throw that one out. So we have 4 solutions to this problem: pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. Okay, so solve for the double angle, but then you're basically, think of you're cutting everything in half. But then you're still finding the solutions between 0 and 2 pi. Okay, I hope this helped. Now, these are, can be a little confusing the first time you see them. And what makes them more confusing is you'll see other equations that have like a cosine of 2 pi in it, but it'll also have a cosine of pi or a sine squared of pi. Or if you have other trig functions in here, then you want to change your double angle using your identities. Your teacher gave you some double angle identities, and you're going to use those for other problems that have other trig functions in it. Okay, if you're not sure what I'm talking about there, just ask me next time and I'll explain. Anyway, but this is how to solve a basic double angle. Hope this helps. We will talk to you soon.